That's the only formula on the Courtney Pierce that has sine of 2x. So we're going to use that. We don't have any other choice. Do we know any information that we can plug into that formula? Sine of x is 1/3. So we plug that in. But we also need to know the cosine of x. Oh, if there was a way to find the cosine of x given the sine of x. There is. The Luther circle. Given the sine, find the cosine. Is there a path from sine to cosine on the Luther circle? It's a one-click. It's an identity. We did much more difficult problems than this in 14.3. So all you have to do is do the identity sine squared plus cosine squared equals 1 and find the cosine given the sine. Once you find that cosine, plug it back in. So really what we're doing is we're trying to fix a problem, but now what we have to do is we have to go off to the side and fabricate this little piece to use in the solving of our problem. Okay, so we're going off to the side here, and we have to make a cosine. So we put in the 1/3 for sine. 1/3 squared plus cosine squared equals 1. 1/3 squared is 1/9. Subtract the 1/9 to the other side. And at that point, I'm sitting at cosine squared equals 8/9. Okay. Square root. Sorry.
No, you're fine. I didn't want you to try.
So now I have cosine equals plus or minus root 8/9. We need to simplify that. Square root of 8 is 2 root 2. And the square root of 9 is 3. And then, as Laura said, since we're in 0 to 90, the cosines are positive. So off to the side, we have created a cosine of positive 2 root 2 over 3. And that's the piece that we're going to take and we're going to wedge it in right there. So we go back over to the main problem. And we have 2 times 1/3 times 2 root 2 over 3, which is in essence 3 fractions. 2 over 1, 1 over 3, and 2 root 2 over 3. And as we talked about yesterday, to multiply fractions, we're going to go straight across. And we end up with 4 root 2 over 9. Here we have find the cosine of 2x if the cosine of x is negative 2/3. And we're in 180 to 270. What do you see when you look at your Courtney Pierce for a double angle formula for cosine?
Cosine squared at, there's lot.
There's lot. There's 3 of them. So you get to pick one. So let's try to make an informed, educated, efficient decision as to which one we should choose. And I want you to feel passionate about it.
I feel passionate about this. I'm very passionate that it should be the last one.
So I want to reason.
Because we don't have a sign given, and this one doesn't have a sign in it, so.
Here we go.
We just said
Okay.
it.
Bailey and Sierra both said the same thing correctly. They want to choose the last one because they don't want to have to go off to the side and do 12 steps worth of work. And if you choose the last one, the only thing you need is cosine.
Wait, why don't you have to go into the
Because you would have to go find a sine off to the side. And the last formula doesn't need a sine. It just needs cosine. See what I mean?
Oh, yep, I get it.
So all we have to do is plug in the negative 2/3. So Bailey and Sierra are exactly right. We're going to plug in negative 2/3. And then we just have to do that correctly. Negative 2/3 squared is positive 4/9. You really don't need a calculator for that. Square the 2, square the 3. 2 times 4/9, you really don't need a calculator for that either. 8/9. And 8/9 minus 9/9 is negative 1/9. That's really it. So they just have, the half angle formulas just have cosine, which is really good if I give you cosine. If I give you sine, then of course you would have to go off to the side to find your cosine. You'd have to fabricate a cosine off to the side. In this case, though, Santa Stromberger has given you the cosine.
Gosh.
Derek? So the formula for cosine x over 2 is plus or minus the square root of 1 plus cosine x over 2 on your Courtney Pierce. The cosine of x is given to be negative 2/3. And so we have to somehow get through this thing without messing it up. 1 plus negative 2/3 is 1/3. 1/3 over 2 is 1/6. Square root of 1/6 is square root of 1 over the square root of 6. Square root of 1 is 1. And now I've got to get rid of the root on the bottom, like we've done all year.
So it's going to be root 6 over 6.
Right, you multiply top and bottom by root 6. We would end up with root 6 over 6. I'll let you get caught up there, then we'll talk about the plus or minus. We are not dealing with x in this problem. We are dealing with x over 2. And in the given blue problem, I gave you the interval for x. So when we try to determine positivity, we cannot look at that interval. We have to look at the interval for half of that. So we have to actually cut the interval in half. And when we look at the interval for cosine, we're looking at 90 to 135. So we have to cut it in half. So the cosines from 90 to 135 are negative. So the answer is negative root 6 over 6. We're going to do a verification question. We'll do this one together. Then I'll let you try a couple on your own. This one, easy because I see a formula right there. What I see is this. And that's on my Courtney Pierce. So the first thing I'm going to do is I'm going to change that to what it is on the Courtney Pierce, which is plus or minus root 1 plus cosine of x over 2. Now, is that helping me get closer to the other side? Yes, because I can see that the root and the square are going to end up canceling. So I'm not afraid of putting a square root into the problem because I know it's going to go away. So I see that. I change it. And now, like I said, whenever you square a root, the square and the root just fight each other off, and all you're left with is what's inside the root. So when you square that parentheses, what you have is just the innards of the root.
How do we know if it's plus or minus?
It doesn't matter, because when you square a positive or you square a negative, you end up with the positive.
Got it.
Then your 2's cancel, and I believe
When you can draw
that we
straight
match. It's an old check mark. When I was younger.
line. Oh my gosh.
The check mark is back.
Okay.
That's when I was younger. Minutes left, Lar.
On the left side, I'm going to change that using the double angle formula, because that's the only thing I know how to do with sine 2x. On the right side, I'm going to change cotangent to cosine over sine. Then I see that on the right side I have a sine on the bottom and 2 on top, meaning I could cancel 1 from the bottom and 1 from the top, leaving me 2 sine x cosine x equals 2 sine x cosine x.
No, wait. How do you get 2 sine x and cosine x?
On this side, the right side,
Yes.
because you canceled 1 off the bottom and 1 off the top,
Yeah.
so there's 1 left on top.
Because it's squared.
Because there was 2 on top. There was a squared.
But then what happened to your 2 cosine?
It's still there.
No. How did you get
You're gonna get yourself in the
What if I
net.
got
Okay. The thing that I would do, I'm trying to get the sides to look the same, kids. I have a sine squared over here. I have cosine 2x formulas all over the place on my Courtney Pierce. I'm going to change cosine 2x to the one that looks most like the other side. So I'm going to change cosine 2x to 1 minus 2 sine squared x. So I'm leaving everything the same except this right here is becoming this. That's the only change I made. Now I have to distribute the negative through the parentheses. When I distribute the negative, I get 1 minus 1 plus 2 sine squared. Somebody get out their calculator and do 1 minus 1 for me.
0?
0. So we have just 2 sine squared x, because the 1 minus 1 cancels. And half of 2 is 1. So Bailey, see how close you were?